Hi, welcome to another episode of Math Made Almost Bearable. Today, I'm Frank Kelly, by the way. I'm going to try to show you some different population models, and I want to show you that some of the alarmist models, this is called an exponential model, as opposed to this one where there's kind of a leveling off of population, that maybe we don't need to be quite as terrified of population growth as some people would like us to think. In this model of population growth, we just have population just skyrocketing out of control. That's called the exponential model. This is a model that's a little bit different. This is a model that says population starts growing real fast, but then it kind of levels off after a while and approaches some theoretical maximum that we'll call M. Okay. Now, what I want to convince you of is if you look at this place right in there somewhere, you notice this curve seems to be increasing at an increasing rate for a while, and then it's increasing at a decreasing rate. And there's a place where it switches from being increasing at an increasing rate to increasing at a decreasing rate, and that point is called the point of inflection. And notice that when you're near the point of inflection, the graph kind of looks like a straight line. Kind of looks like a straight line. Now, the mathematical theorem that I'm going to show you says that at that point of inflection, you're halfway to the top. That's what I'm going to try to convince you of. Now, for those of you that don't know any calculus, what I'm going to say for the next 2 or 3 minutes may not make any sense to you. So you could snooze for a little while, and then when I get to the result, then come back and pay attention and join everybody who understood the calculus, or at least had the calculus, and we'll talk about what this means. Okay. Well, this kind of a curve that is a pretty standard way of modeling a lot of population growth has this property. The rate of change, the y prime, is equal to some k, some growth constant, times the population times this other factor. Now, when you have something like this, that's your standard exponential growth model. What this is saying is you've got the exponential growth, but as the population gets closer to this theoretical maximum, the rate of growth will slow down as it does up here, you see. Now, you can actually solve this and actually calculate y, but we don't need to do that to prove what I want to prove. What we need to know is a little bit of calculus. And the point of inflection, this thing I'm looking for here, is the place where the derivative of y prime, the so-called second derivative, equals 0. So when I look at this equation, I want to notice that k is greater than 0, y is greater than 0, y prime is greater than 0, and y is always less than m. Those are the 4 things I need to do. Well, let's get rid of this pesky exponential model. We don't really need that right now. And now we're going to take this expression right here, and we're going to find its derivative. We're going to find y double prime. And in order to do that, we need to know a rule of calculus called the product rule. And the product rule says you do this. You take the first expression, that's ky, times the derivative of the second expression. The derivative of this is just going to be minus y prime. And then you take this times the derivative of this. So that's going to be ky prime times m minus y. Okay? So there's y double prime. Now, if you factor out, what you'll see is common to both terms. There's a ky prime in both terms. I'm going to factor out ky prime. And what I'm going to have left if I factor out ky prime is I'm going to have a minus y, and I'm going to have an m minus y. So I get y double prime equals ky prime times m minus 2y. And what we want to know is, when is that 0, so we can figure out what this point of inflection is. So we set this equal to 0. Now look, the k is not 0. The y prime's not 0, so the only thing that can be 0 is the m minus 2y. And if I set m minus 2y equal to 0 and solve it, I'll get that y is m over 2. So this tells you that the point of inflection on this graph is halfway to the maximum. Now let's think about human. Now, those of you that don't have no calculus, come back and listen. Now we can just take this result. Notice it wasn't very many lines. You could notice that. You could say, gee, if I just had calculus, I could do these 5 steps. But if you haven't had calculus, sections are open, so enroll. Anyway, so y equals m over 2 is the point of inflection. Now let's imagine our situation. We're the human race. We're growing. We went past 6 billion a while ago. Some people think we're going to end up with 40 billion people. Well, not if we're on this curve. Because what would we have to do? See, if we don't know what m is, maybe we could guess where the point of inflection was. And then all we'd have to do is double that and we'd get maximum human population. Well, take out an almanac, look at some data, and I think you'll find out that the m over 2 seems to be right around 6 billion. Remember what you're looking for. You can look at almanacs and they'll tell you the history of human population growth. And it looks to me anyway like that thing kind of turned linear around 6 billion. We're somewhere between 6 and 7 right now.